And we're back with another PicoCTF challenge. This time we're looking at Script Kiddie, a web exploitation challenge. This was requested by Faraz. Hopefully I didn't butcher your name too much. I do take requests. I appreciate all your comments, all that. It helps me out with the YouTube algorithm. So by all means, if you have something you want me to do, throw it up in the comments. Description: the image link appears broken, and we're given a website to hit and then a hint. This is only a JavaScript problem. So let's go ahead, let's open up this page and see what we're working with here. So we're given a submit box right here and an input. So I'll just put in a bunch of ones, and we don't get anything. So let's go ahead, let's open up the inspector and try to get a sense of what we're working with. We will, probably be easier here to view the page source. So we can see we're getting jQuery at the top. jQuery is a public library. That's not unique, that's not of interest. And then we have a script that we define here. And we seem to be calling it, so we have a form on submit. We call this thing assemble PNG, taking our user input value. So let's take a look at this script right here. We have some var bytes, which is an array. We do a get, which is a server request. So think of it like when I go to Google or something like that, I make a request to Google with a get. That's what's happening here, is we're doing a get HTTP request. And then with whatever this returns, so the response, then we seem to fill in bytes. And we have our assemble PNG function here, which performs some kind of operation. Now, immediately I see a key here. So let's go ahead and let's grab this key and let's see what we can do. So we get something new here. What we get is, it seems to be a broken image. You can see the image ID is equal to area, and then the source, it's trying to do a base64 encoded PNG. So just to give you a sense of what is going on here, let's copy and paste this. So normally when you're doing HTML, you can define an image and you give some kind of reference. So right now we have two images. I'm going to give a source of, let's take the Google image. Copy the image link. We'll bring it over. You can see it's a GIF. Cool. So we have an image that appeared. So normally what you would do is you would give a resource. But this seems to indicate you can also give base64. So let's check that out first. So I have a picture of Mario, a PNG of Mario. And we're only going to look at the top of this Python that I've defined. Here I'm going to open up the Mario PNG. I'm going to read it as a binary. And then I'm going to base64 encode this. So let's go ahead and let's do that. And let's grab, I'm going to copy my value. We're going to go back here. And we are going to demonstrate how this would work if this was proper base64 for a PNG. All right, cool. So this can work, but apparently what we're feeding it, this base64, doesn't seem valid. So before I start to get into this code, I'd really like the ability not only to debug, which I can do in the browser, but I'd also like to be able to change some of these variable names and put comments and stuff like that. So we're going to look at how we can do that. So what I'm going to do is I'm going to do a wget for this page in my downloads directory. And what that's going to do is it's going to download the HTML page. You see right there we have an index.html. So this is going to be much nicer to deal with. So we know we have these bytes that are coming across the wire. What do the bytes look like? We can find that out if we go back here, we refresh, and we look at the different requests. So we see our initial request, which was, well, that was less helpful clicking on it, sorry, for the HTML page. So we can see it's a doc type HTML. Then it calls and requests jQuery, which again we saw above. And then it does a GET request for bytes. So we're interested in those bytes. We want to know what those are. And when we look at the response, we see a long series of numbers. And they seem to go up to about 255, so it's probably bytes. So let's go ahead and let's grab this for the time being because this might be useful. Dump that in. And let's keep looking at what we have here. So we've covered this at this point. I just want to get rid of things that are complexities, you know, so like making a network request. That's an unneeded complexity. Let's just give it the value. And let's make it properly formatted for an array. And let's just drop it in. And I'm going to slowly simplify this until I can understand exactly what's going on. So we've got our user input, we have a length that's defined, we have a key, variable called shifter. We take a look at our user input and we ask if the length is equal to 16. If so, then we replace the key. All right, so that's valuable to know. So it has to be 16 digits at the very least. Then we have this thing called result. And we start doing a loop over that length, and we do a shift. It says there's a shifter, and for each of the keys, which was our prior user input that was taken, we get the char code, which is the ASCII code, and we subtract 48 from it. So that seems like a pretty weird number to subtract. So it's worth taking a look at an ASCII table to try to get a sense of what this might be. As we look at the decimal column, we can see that 48 is 0. So it's reasonable to assume that what they're doing is, so they're taking string input, so something like 0, 1, 2, 1, 2, 1, whatever, and they're taking each value, so they might take the first one, the 0, and they want to get what the actual value would be if you represented this as an int. And the way you could do that as a shorthand is you could turn it into the char code, and then you could subtract 48. So as an example, 0 as a char code is 48, and if you subtract 48 from it, then you end up with 0 as an integer. This will make a little more sense if we turn on the debugger here. That's probably what I should have done to begin with. All right, so I'm going to begin debugging. I'm going to submit. You see we're paused at this point. Stepping through. Our key's length is equal to 16, so we're going to replace. I mean, it's not very meaningful because it was all zeros before, and we're replacing again. But okay. We get into our loop, and then we're doing this char code at. So let's go ahead, and let's grab this, and over in the console, we'll play around with this. So our key, again, looks like all zeros. The char code at 1, or at position 0 is 48. And so if we were to subtract 48, that seems like just a really easy way to quickly change something into an integer if it's a valid integer. So for example, let's do 1, the char code there, minus 48 is 1. So if this isn't, if you're a little new to programming, this might look like a 1. It's actually, it's a string. So it's not something that you can use for like mathematical operations because it has a different meaning. It's the written value of 1. So, okay, going back to the debugger for a second. So we're doing some kind of shift, and then we get into a whole bunch of complicated logic, and this sucks to look at. And so the first thing I'm going to say is we should make some changes here. Hey guys, Mike from the future here. So as I was going through and editing this video, I realized I didn't do a great job of explaining kind of how I proceeded to reverse engineer this and work through. And so I'm retouching this now. So what we have is we have this index.html, and I'm going to start making changes to it based off of my understanding, and I'm going to be relabeling things, making them simpler. We've been debugging over here off of the server's copy. The issue is the server is not going to pick up our changes. So what we're going to do is we're going to begin serving our index.php or .html. We're going to serve it with Python on port 8080. And this is going to do something really nice for us. It's going to allow us to pick up our changes. So now, if I make a change down here, so let's go back here, and let's say I change this. I'm going to just put a comment just to quickly show you. Go back here and refresh, and you can see we're picking up live our changes, which is great. So now we can do our static analysis, meaning we can read through and try to understand. And then when we want to go back and do dynamic analysis, running through, seeing live values in the system, we can do it here. So with that in mind, we got to about this point. We talked about the shift, so the shifter value. And now what we'd like to do is we'd like to understand things more. So we're doing this for loop, and we're looping for I less than length. And we know this has to be 16, which is the length of the key. So let's go ahead and let's change that. What we're going to be doing is we're going to be refactoring just so that everything is as easy as we can make it, so that we can understand things that are more complicated, like this inner loop. We'll throw some comments in here. I think this maps to 0 to 9 range. Then we can start to see we've got another loop which is running over byte.length. It'd be really interesting to know what byte.length is. So let's go ahead. Let's go over here, set a breakpoint, refresh our page, submit. And let's check out what byte.length is. 704. So let's take a note of that. Where were we? All right. So this seems to be going over each key index, right? Because it's going from 0 to 16 and it's pulling our keys, and we get a shifter value out. So rather than I'd like to call this key position. And then we're doing something over bytes.length divided by the key length. So 704 divided by 16. Let's get a calculator. Which is 44. So we are looping until we hit 44. And then we've got some math that looks pretty complicated, but we can summarize it as we are calculating a byte index. So our byte index, which is equal to that value. And then we have a result index, which is equal to this value. And this may not seem like it helps a ton, but it does. It really does. It's very difficult to reason about things when it's just a big blob, one-liner. So, all right. Now I still don't understand, so I'm going to go back and I'm going to get a better sense here of what's going on. I'm going to refresh the page. Submit again. I want to set my breakpoint. It may have moved. And see what we can understand about what's going on. All right, so we have a for loop here that's running 44 times, like we said. We will step over and we calculate a byte index of 32 and a result index of, let me display it over here in the corner. So the byte index is 32 and we're looking for the result index is 0. Actually, it'll be easier. I'll add these to watch expressions. And I thought I could try like this. I'm just trying to get this above my head. I know my head is somewhere right around there from the overlay. Result index. Perfect. We can make this a little bigger. So we're getting the first position of this result index is the 32nd index in the byte array. And we're setting that value. So let's set another breakpoint. And we will run through a few times. And so now we can see we're setting the 16th position in the result index, the 32nd, the 48th. So we're going by 16 each time, which doesn't seem like a coincidence because our key length is 16. So what we seem to be doing is in each block of 16, we're setting the first byte and then we're moving on to the next block of 16. So let's go ahead and let's see what happens with the next key bit. So I'm going to let this entire loop run through. Now we're on to the next key bit. So we seem to have done the 0th key bit. And we want to see what we're going to see now. And we see we're doing 1, the first result index. Next we're going to do 17, then 33. So again, we're going by 16 each time. So my intuition is we've scrambled this somehow. It's a shift. And the byte index, or the bytes, are the scrambled results. And we're trying to unscramble into this results array based off of our key input. Let's continue down and let's see what else we do. So at this point we have results, which we think we're trying to make a PNG. And we're doing some operation where we take the last index, result.length -1, And if it's equal to 0, while it's equal to 0, we do a slice. So we would take, let's see what these values are. If this was 0, then we would chop it off and then keep chopping off until we ran out of zeros. So what this is doing is it's removing trailing zeros. And then if we continue down, we can see we're doing a get element by ID for area, and we're setting the source. So if we look at the main page with the inspector, we can see we have an image with the ID area, which has a source. So this would be us trying to set, for example, Mario as a PNG or something else. So at this point, let's record our findings just quickly. So this removes trailing zeros, tries to set source of image element, and then this tries to de-scramble a PNG, and this guy would be, let's call him PNG bytes. That's what we want it to be. All right, so that was my process for understanding what's going on. Now I'll go back to some stuff that I had pre-recorded. Now we have a pretty good idea of what's going on. So I'm gonna bring you guys over to a quick diagram just to kind of reinforce. There is some original image, which was a valid PNG, and it had these 16-byte chunks, which, you know, that's the size of our key. And what we seem to have is somehow scrambled. And so you can see over here all the different blue elements, and I got lazy. I didn't do, it's not true to scale or whatever. You know, there are just 4 here and 4 green elements, and there would be these gray elements. They all were scrambled all around. And so the question is, how do we recover from the scrambling? And the answer is we can look at defined elements in the PNG standard. So clearly, like there has to be, if you want to be able to read these images, there has to be something that says, hey, this is an image, and this is the way that you read it, and this is what you can expect, and there's a defined format. And we can look up the format here, or you could look it up in the specs. So as an example, the PNG starts with a signature, and then it has some additional header information and an image end. So if we were to go back to our Mario example and do ghex on mario.png, what you're going to see is the first couple bytes say the words PNG, 89, 50, 4E, 47. Same thing here, 89, 50, 4E, 47. So what we have is, we know for one block, we know 8 characters or 8 bytes that have to be there. And so we can get a sense of like, how is it shifted and what could the possible shift values be? And towards the end, we also have a defined area that's 8 bytes, and it's the final 8 bytes. And we know it also has to be these values. So between those two, 8 bytes at the beginning and 8 bytes at the end, we have 16 bytes. So we can figure out all the shifting that happened across a block. And so once we know the shifts for one block, we can apply it to all the blocks, and it'll work out. There was some shifting that occurred here for these guys, for this blue block, some shifting that occurred for the green block, etc. We know half of the green block's values that it has to be, and we know half of the blue blocks. So for example, we know this guy has to be 89. So if we look and we find, well, where are there 89s? And there might be more than one. You know, I have like this nice, it's green, it's blue, it's whatever scheme, but you know, there might be multiple 89s throughout there. But one of the 89s that we can arrive on based off of the math that we're doing has to be the shift for this key. All right, so based off that shifting math, what we can do is we can work backwards. So we know we have this defined setup. So the current block plus some shifter, which is just our offset, you know, it's a number between 0 and 9, times our key length, taking the remainder of byte length, plus our key position, gives us an index to look at. We want that index to be 89, to be the very first thing in a PNG. So I've already done this over here. I took the known bytes from the definition I just showed you. So I took these guys and the last date as well. That's what you see here. I'm going to replace my bytes in here just because it may have changed. You will probably get different values than I got. So let's go ahead and let's take the freshest values. So I have the bytes. So we've got possible key values. And that means for each of the 16 positions in the key, there are different places where we might be able to find those values. We are going to loop over the key positions. And let's see. Sorry, I was doing a little editing. All right, so we are going to loop over the key positions, and for each key position, we have a known byte, which we got from the PNG definition. We know also which block does that come in. So for the stuff that starts off, the stuff that says PNG, that's the very first block. For the other stuff, it comes from the very last block. So we're saying here, if the key position is in our first 8 bytes, then we are looking at the first block. Otherwise, we're looking at the last block. And then we have some key possibilities. So for this key position that we're looking at right now, there are going to be some values that match what we want. So they're going to be like the 89 that leads off. So let's go ahead and let's find, so this is Python, it's a for loop, and what it's going to do is for all the byte values, we get the index and the byte, and we want to know if the byte is equal to the known byte, so in this case 89, then we'll take the index. Actually, I'm going to begin debugging because this will be much easier if you guys can see it being debugged. It's stuck. Why is it stuck? Let's see. Okay, there we go. All right, so key position 0, we have a known byte, which this is just the decimal representation of 89. So if we looked OX89 is equal to 137. All right, so everything makes sense. Our current block is 0. And we want to know where in bytes can we find 137, the value 137. The answer is we can find it at position 96 and 321. Just to prove this to you, I'll go over here and I'll do bytes 96. Oops, there we go. All right, so we see it there, and just trust me, the other value, 321, that's there too. Although I guess I'm here, I'll show you. So those are our two possibilities. So now what we want to do is, for the values we could have for the key, which we think is between 0 and 9, we want to do that complicated math. And we want to get a byte index. So given the current block and the shifter value, which is just the key times the length, taking the remainder of the length in bits plus the key position. All right, that gives us an index. It's index 0. Is that index, does it have the value that we want? Does it unscramble things appropriately? No, it doesn't. What about byte index 16? No. All right, so I'm going to press F5 and let it run, and you can see now the byte index is 96. So we found a value that works. So now we're going to run to the next key position. So we were looking at key position 0. Now it's time to look at key position 1. And I'm just running ahead now because we've seen how it works. The known byte is 80, and we found a possible key value of 6. All right, so clearly we're going to keep going through all the different key values, and we're going to find which positions would unscramble. And that seems to have worked. And one of the really nice things you can see is we only have one position for each, or one value for each of our positions. There could have been, for example, more 89 values in there. So like there's nothing to say that this starting guy, hex 89, that he can't be somewhere inside of the image. But in this case, they were really nice to us, and there were no duplicate values. So if there were duplicate values, we'd have something like 1, 5, and 7 as a possibility here. And then we'd have to try each one of those to see, because any one of those scrambles could be equally valid. But in this case, it's easy. So what we're going to do, we could write this all out, but that's kind of a pain. So instead, we'll do a little Python here. We're going to do, oh, I already did it. So this is nice. Let's see. L equals possible key values. I'll explain this in just a second. So what we have is we have a list of lists. You can see up here a list, and then the sub items are lists. What we'd really like to do is we would like to combine all these down. So what I'm going to do is I'm going to take the first element of each list using this lambda. So now you can see they're no longer lists inside of lists. I'm going to do another step, which is I'm going to turn them all into strings. So if we look at L now, why didn't that? Interesting. All right, this is kind of just a shortcut to avoid me typing out a bunch of numbers. So it's not super important that you understand. Just know that I'm doing a shortcut here. All right, there we go. Again, sorry about that. Not super important. So let's go ahead and let's submit now what we think is our key that should descramble the image. Let's let it run through. And we're given this QR code. So let's go ahead, let's save it as qr.png. And then you got a couple of ways that you could solve it from here. There is a QR reader on the web where you can just take this, drop it in. There's also a nice utility called zbar image that you could use. Let's see, I'll use zbar image for just a second here. And you end up with a flag. So let's go ahead, let's go back, let's submit it. And if this was helpful to you, please like, comment, subscribe. Again, I take suggestions, recommendations, requests, what have you, if you have a challenge you want me to do. Anyway, have a good day. Bye.